Welcome to Chapter 5, Section 5, entitled Apply the Remainder and Factor Theorems. To begin with, we need to talk about polynomial long division. It's the same process as normal long division, except that you're using polynomials. So normally, you would have 221 divided by 13. You would put the bottom number outside of the long division. 221 goes here. You decide how many times does 13 go into 22. Well, once. 1 times 13. You multiply. You subtract. And multiply. Let's see, what times 13 gives us close to 91. Let's see here, 9. Definitely not. So 8, maybe. Nope, 7, I think. 7 times 3 is 21. Carry the 2. 7 times 1 plus 2 is 91. 0, so it's 17. And basically the 0 is a remainder over 13. So 17 and 0/13 is just 17. But now you're going to do it with something like x squared plus x minus 2. And you're going to divide by x plus 2. All right? And so you set it up exactly the same way. The x plus 2 goes on the outside. X squared plus x minus 2 goes on the outside. So as long as you remember the basic process of this, the only thing you now have to remember is that you're multiplying variables. So what times x gives me an x squared? So x goes into x squared. What times x squared gives you x? Well, an x. X times x is x squared. X times 2x is 2x. And you subtract. So now you subtract, so this becomes, let's see, 1 minus 2 becomes negative x minus 2. What times x gives you negative x? Well, negative 1. It gives us a remainder of 0. So that means this divided by this is equal to x minus 1. If there was a remainder, it'd be 0 over x plus 2. That's how this is set up. Polynomial long division. We're going to use synthetic division, which does the same thing. Same thing as the polynomial long division, but only works when you are dividing by something that is a binomial. If we did this as x squared, then you cannot use synthetic division. Synthetic division is just like synthetic substitution, where you put the coefficients across the top. You put a number out here in front, and you get a remainder of 0. All right, so we're going to use long division to do this example. Now I'm sure there's a bunch of work underneath it, but it's easier for me to show it in this way. So let's do x squared plus 2x plus 4 divided by, I made this extra long because you cannot Do not forget about missing terms. What that means is you're missing a 0x cubed. Okay, barely fit it in there. All right. And the first thing you need to look at is you need to look at only how the x squared and the 4x squared, how you can get a 4x to the fourth out of an x squared. So don't worry about any of the rest of this stuff. Only worry about x squared and 4x to the fourth. Because all you need to look at is you need to say to yourself, all right, what times x squared what times x squared gives 4x to the fourth? Well, there's a 1x squared and there's a 4. So you know it's got to be a 4. You got to have a 4 as part of the what you multiply by. Then an x to the fourth and an x squared. Well, there are only 2 x's here and 4 here, so it has to be an x squared. And you line up this right here over top of the x squared. We're lining things up. It will make things easier. Once you do this part, you now just look at it and say, all right, times this times x squared gives me 4x to the fourth. Then this times 2x, well, 4 times 2 is 8. X squared times x is x cubed. And then 4x times 4 squared gives me 16x squared. And so when you combine this minus that cancels out. 0 minus 8 gives me negative 8x cubed. 5 minus 16 gives me a negative 11x squared. And as before, bring down a 9x. And so now you look at you use the x squared, and this moves to this, and you think of the same thing. What times 1x squared gives negative 8x cubed? Well, it's got to be 1 times some number to get negative 8, so that's for sure a minus 8. And what with an x squared? An x. So you get a minus 8x here. And this process seems long, but it is step by step. Negative 8 times x squared gives you negative 8x cubed. Negative 8x times, basically you're taking these now it's this times that, this times that, negative 16x squared, and this times that, minus 32x. And when you subtract, of course, this cancels. Negative 11 minus negative 16 becomes 5x squared. Negative 9 minus negative 32 becomes plus 23x. And of course, please bring down the 18. And now, you take this circle and and you're looking at the x squared and the 5x. and you say to yourself, what times x squared gives 5x squared? So why don't you pause the video real quick and see if you get this last part right. So pause it. When you're done, of course, unpause it. So you should be coming back and saying to yourself that what times x squared gives 5x squared. All you have to multiply by is 5. So you put a plus 5 and work it out. 5 times x squared, 5x squared. 5 times 2x, that's plus 10x. 5 times 4 is plus 20. And when you subtract, this cancels out. You end up with 13x minus 2. This is the remainder. All right? Your answer should then be 4x squared minus 8x plus 5 plus the remainder divided by the divisor. All right. So this example should not take 8 minutes. You should be able to do these much faster than 8 minutes. And I'll do the guided practices here in a little faster than 8 minutes. But that was our first time. So guided practice number 1 says you do take 2x to the 4th plus x cubed plus x minus 1. And you're going to divide by all right. So pause the video and set up this problem. All right, so now you should have this set up. And we're going to go ahead and think to ourselves, what times x squared gives me x to the 4th, or 2x to the 4th? Well, we know we're going to multiply by 2. And x squared times x squared gives me the x to the 4th that we're looking for. So now go ahead and multiply 2x to the 4th. 2x squared, and that's a plus 4x cubed. And a minus 2x squared. Please do not forget that we are subtracting all of this. So 2x to the 4th, 2x to the 4th, that becomes 0. An x cubed minus a 4, that's negative 3x cubed. And that's a plus 2x squared. And you drop down the next one. And now we think to ourselves, what times x squared gives me negative 3x cubed? Well, we know it's going to be a minus 3. And x times x squared gives me the x cubed. So multiply. Subtract. This becomes 0. And this becomes, let's see, 8x squared minus 2x. Bring down the minus 1. And now, 8x squared and x squared. What do you multiply x squared by to get 8x squared? All you need to multiply by is the 8. And when we do our multiplying, 8 times x squared, 8 times 2x, 8 times negative 1, and subtract. This, of course, becomes 0. This is subtraction, so that becomes negative 18x plus 7. So my final answer, you end up having plus negative 18x plus 7 divided by the divisor, x squared plus 2x minus 1. You're going to want to rewatch that or try it on your own again to make sure you know what you're doing. But we're going to do number 2, guided practice number 2, which is x cubed minus x squared plus 4x minus 10. And you're going to divide that by x plus 2. So you pause the video and set up the problem like long division. All right, so you should have paused it, and this is how you set up the long division. And again, you think to yourself, what times x gives me x cubed? Well, that's an x squared. So then we multiply. And subtract. That's a 0. Then we look at ourselves and say, what times x gives me negative 3x squared? And then we subtract, so that becomes 0. This becomes 10x minus 10. And now what times x gives me 10x? Well, it should just be a plus 10. When you multiply, you get 10x plus 20, which gives me a remainder of negative 30. So we have this is our answer plus the remainder, which is negative 30 over what you're dividing by. So this is polynomial long division. All right, the remainder theorem. If a polynomial f of x is divided by x minus x k, then the remainder is r equals f of k. Basically what that means is when you're dividing these, if you're dividing by an x minus a number, you can come up with the remainder by simply substituting the k in for x. All right, and that brings us to synthetic division, telling us that this is the remainder, all right, because it's like synthetic substitution. And a couple things here. When you have x minus k, let me put some steps. Let me write some steps down here, then you can pause the video. All right, you should pause the video and write these down while I explain them. But what you're going to do is, for synthetic division, you're going to set up synthetic substitution. So notice 1, 4, negative 5, 3. Then x minus k equals 0 is what you substitute. So if you set this equal to 0, then the x value is negative 2, which is what you are substituting. Then these bottom numbers are the new coefficients. And you're going to see how that works out here in just a minute. And basically, the reason why is if you're taking x cubed plus 4x squared minus 5x plus 3, and you're dividing it by x plus 2, you're basically making the top 1 degree less. So basically, the x cubed becomes an x squared. The x squared becomes an x. The x becomes just a number. And then whatever this is the remainder. All right? That's how this is set up. So let's do synthetic substitution. bring down the 1, multiply, add, multiply, add, multiply, add. So these numbers here are the new coefficients. And I just got done saying that an x cubed becomes an x squared. An x squared becomes an x becomes the constant, and so our answer is x squared plus 2x minus 9 plus the remainder divided by the divisor. That is synthetic division. You can see it is so much faster than the long division method. So we'll do another example of that in a minute. But a polynomial, f of x, has a factor, x minus k, if and only if f of k is equal to 0. All right, this is basically if the remainder is 0, then it is a factor. So let's look at guided practice number 3. You're going to use synthetic division to do x cubed plus 4x squared minus x minus 1. And you're dividing by x plus 3. All right, so synthetic division, you are setting up synthetic substitution. So the numbers, coefficients, go across the top. Then this right here, set it equal to 0. That means x is negative 3, and that is what you are substituting. So go ahead and use synthetic substitution. 1, multiply, add, multiply, add, multiply, add. And now, remember, you're making it 1 degree less. X cubed becomes x squared becomes x becomes a number, and then this is the remainder. So my answer to number 3 is x squared plus x minus 4 plus the remainder over the divisor. And that is how this works. So you should pause this, make sure you get this down, re-watch this part if you were confused, because we're going to go ahead and do number 4 as well. So number 4 is to use synthetic division to take 4x cubed plus x squared minus 3x plus 7 and divide all of that by x minus 1. So following this setup over here, we set up synthetic substitution. So we put the coefficients across the top. We say what makes this here equal to 0? Well, then x equals 1, and that's the number that goes here. And at this point, it's synthetic substitution. Now, the bottom numbers are the coefficients. So that means this used to be an x cubed. Now it is a 4x squared plus 5x plus 2. And the remainder of 9 divided by x minus 1. So this is how we can divide polynomials using synthetic division. All right, so factoring a polynomial now. We're basically going to use synthetic division from here on out. So setting up synthetic substitution, saying what this equals to 0, this is 0, means that we're going to test x equals 3. So we put a 3 here. Drop the 2, multiply, add, multiply, add, multiply, and add. And so what we have now, since this right here, the remainder, is 0, then you know this right here is a factor. And what we went from is a 2x cubed to a 2x squared, minus 5x minus 12. So when x, we have to factor this completely. So we've already factored out an x minus 3. So we now have x minus 3, and now 2x squared minus 5x minus 12. All right, so we have part of this done. What we need to look at now is the fact that 2x squared minus 5x minus 12, we need to check to see if it's factorable. So we use Waddell's method. We say 2 times negative 12 is negative 24. We now write all of the factors of 24, and we have to put the plus or minuses. And since this is negative, we have to flip the plus or minuses in order to get it right. So, which of these factors add up to 12, or add up to negative 5? Well, we know it's definitely not this one, or this one, or this one. So negative 5 we get from a positive 3, negative 8. So 3, negative 8. Next step was to divide by a, and our completely, which ends up being negative 4 over 1, which means I'm completely factored when I do, here's x minus 3, and then 2x plus 3, and x minus 4. This has been completely factored. All right, so we're going to do some guided practice and a few more. So practice number 5. Okay, so like I said, guided practice number 5, factoring completely. If you're given that f of x is x cubed minus 6x squared plus 5x plus 12, and you're checking to see if x minus 4 is a factor. So, like we're doing, like we have here, we need to set up the synthetic division, put the coefficients across the top, and this is the key. Whatever you're dividing by, or whatever you are choosing as a factor, you say, what makes this equal to 0? And that's the number you put in there. 4 minus 4 gives you 0. So you go about dropping down the leading coefficient, multiplying, adding, multiplying, adding, multiplying, and adding. And since we got a 0 as the a 0 as the remainder, you know that x minus 4 is a factor of this whole thing. Now, of course, we need to try to factor completely. So this 1x cubed becomes 1x squared. This minus 6x squared becomes minus 2x. The 5x becomes just a minus 3. So now you have to determine whether or not this quadratic is factorable. And when you look at the factors of c, how do they add up to negative 2? Well, two factors of c that add up would be minus 3 plus 1. Those are the factors. It is now factored completely. If I were to ask you, what are the zeros? What makes this factored equation equal to 0? You would look at this and say 4, 3, -2. And that leads us into the next part. You can use synthetic division to find all of the other zeros. All right, notice here, this is saying this is a 0. A little bit different. We're not looking at x minus 1. All right, we're not doing this. All right, we're looking at the fact that this is a 0. So the zero factor theorem, the factor theorem that says if this remainder is a 0, then -1 is a factor. So let's check. Drop down to 1, multiply, add, multiply, add, multiply, and add. A 0 means that -1 is one of the answers. Now, as before, an x cubed becomes an x squared. A 4x squared becomes a 3x. And now you have to find the rest of the zeros for x squared plus 3x minus 18. And when you're looking for zeros, we know how to find zeros using a graph, using factoring, using the quad formula, using completing the square. So there are a lot of ways we can solve this. Factoring should be your first go-to method because factors of 18 that add up to 3, positive 6, x minus 3. So what we have so far is a -1 as a 0. This right here becomes -6. This one here becomes 3. So those are your zeros, and you can be done with that. All right, guided practice number 8. I'm doing most of the guided practices for you, but for number 8, you have to find all of the zeros for x cubed plus 8x squared plus 5x minus 14. And it's telling you that negative f of -2 is equal to 0. All right, synthetic division, so much easier than other methods. 1, 8, 5, -14. Put the -2 in here, and we had better end up with a 0 at the end. Drop down the 1. Add these together. Multiply, add, we get our 0. And we are now happy with the unibrow. All right. This x cubed, and you're going to get tired of me saying this, becomes an x squared. The x squared reduces by 1, becomes an x. And now we have x squared plus 6x minus 7 to factor. So -2 is a 0. Factoring this, you're looking for factors of 7 that add up to 6. Well, factors of 7 would be plus 7 and x minus 1. Those are the factors we're looking for. That means -7 and positive 1 are the rest of our zeros. All right. So I'm going to go ahead and help you finish these. The long division one, let's try to work it out. You got x minus 4 goes into x cubed minus 6x squared plus 0x plus 9. So, like the beginning of the video, you look and say how many times is x, what times x gives you x cubed? That would be an x squared. So x cubed minus 4x squared becomes negative 2x squared plus 0x. Now, minus 2x, because 2 minus 2 times x, minus 2x times x is minus 2x squared, plus 8x. And when I subtract, you get a negative 8x plus 9, negative 8x plus 9. When you are looking for what times x, you do minus 8. And when I work this out, it becomes negative 8x plus 32. And my remainder, the remainder is 23, negative. So negative 23 divided by x minus 4. That's your solution. Now pause the video if you want to be able to write the rest of this down. I'm going to continue on with the other checkpoint questions. So synthetic division. You put the coefficients across the top. You put the what makes this equal to 0 and work it out. Multiply, add, multiply, add, multiply, add. So my equation went from a cubed to a 2x squared minus 2x plus 3 minus the 15 and the remainder. All right, factor this given the 3, 8, 3, negative 2. You put the negative 2 out there, because what makes this equal to 0? And drop down the leading coefficient. Multiply, add, multiply, add, multiply, add. So we know x plus 2 has been factored. This 3x squared plus 2x minus 1 now needs to be factored. And you can use Waddell's method, but what you're going to end up with is you're going to end up with a plus 1 and a minus 1 and a 3x here and a 1x there. All right, Waddell's method should give you this, or at least something close to this. Let's find the zeros. We find the zeros by knowing 2 is a 0, and the coefficients go across the top. Oops, that's a negative 11. And a 30. Drop down the 1, add, multiply, add, multiply, add. 0. That means 2 for sure is one of our answers. And now I have x squared minus 2x minus 15, in which I need to completely factor. Factors of negative 15 that add up to negative 2. That would be negative 5 with a positive 3, which tells me the zeros are 5 and negative 3. If you missed any of this explanation, you should rewind the video, watch it over again, make sure you understand all of these, and then our class time will be a lot easier. So please finish the guided practices, and then these right here will be the problems we try to complete in class. Good luck.